Hey everyone, here we are in week 5 of online learning. We have our next lesson for the week. Happy Monday to you. Hopefully you're checking this out bright and early Monday or at some point Monday so that you have the rest of the week to jump on office hours. You know, I have office hours Monday and Thursday at noon, so make sure you go ahead and take notes on this video and watch it a couple times. So why don't you pause the video if you haven't already, taken out a piece of paper, pen or pencil, and we'll get through the next lesson. So next we're going to be talking about reflection. So last week, as you can remember, we talked about translation, and translation is when you move a shape. So if we had a rectangle or square and we shifted to the right and then let's say up, it now is placed up here, same size and same shape. So that's translation. Well, this week we're going to be focusing on reflection. And so you can think about, reflection in a mirror. It's mirrored, right? So if you have, let's say this is your mirror and you're looking in your mirror, you're going to be reflected in the mirror and it's the same image, and hopefully you can not laugh at my drawing. Those should be the same size circles, but you get the point. So reflection is when you have an image that's being reflected over some line. So let's get started with some notes here and examples. So a flip, reflection is a flip over a line called the line of reflection. Sorry for the pen that you hear me writing on, but we'll get through this. Okay, so each point, its image are the same distance I guess I could have wrote this out before, but that's okay. Happy Monday, everyone. So each point and its image are the same distance from the line of reflection. So up here, as you can see, hopefully when you're looking at this triangle and then this triangle, you can see how they've been flipped, and they look to be flipped across this line. So see, if I do a better job of drawing this red line. Oh, it's a Monday for sure. Hang in there with me, everyone. All right, well, we're going to go with this. So C is one spot away from this line, and then C prime is one spot away from this line. So it's the same distance across the line of reflection. Don't worry, we'll get into more examples, and hopefully my handwriting improves through this video. Okay, a reflection is also an example of rigid motion. And you learned that last week that there are 3 types of rigid motion, translation being the first one, reflection being another one, and then next week we'll get into the next one that we'll be covering. So common lines of reflections, there's different common lines. The x-axis or y-axis is 2 common lines that an image can be reflected across. Or vertical and horizontal lines in the form of, x equaling a number or y equaling a number. So if I were to say reflect across x equals 3, we'll talk about what that means. And then diagonal lines. So for example, flipping y equals x or y equals negative x. We're going to be talking about these first 2 examples for this lesson, and we'll get into what that looks like on a coordinate plane on the next slide. All right, so here's a couple examples. So let's talk about what it looks like when you reflect something over the x-axis and y-axis. Well, first we need to remember which is which. So remember the x-axis goes horizontally and the y-axis goes vertically. So if I were to draw a point, let's go over 3 and up 2. If I were to draw a point at 3, 2, and I say we're going to reflect that across the x-axis, what that means is we're going to reflect it across. So looking at this x-axis as a mirror. Okay, so we don't really need to worry about the y right now if I'm asking you to reflect it across the x-axis. So it would be the same distance away from this x-axis. Well, it's 2 spaces away. So that means it would be 2 spaces away in this direction, and it would be right here. So that's when you're reflecting it across. So this point would be 3 and then down -2. Another thing to recognize that I'll talk about in a little bit is this coordinate is 3, 2, and then it becomes 3, -2. So when you reflect it across the x-axis, the rule is that you would keep the x and then negate the y value or make it the opposite value. So if it was 2, then it would become negative 2. Okay, so let me erase this. Don't worry, we'll get into some examples. And there are some rules that you can write down in your notebook on I think the next slide. So now I could also say, hey, let's reflect a point across the y-axis. So now we're really going to look at the y-axis here. So if I were to draw a point, let's say down here, okay? So let's name this point -2, -4. So -2, -4 is my point. If I were to say let's reflect it across the y-axis, I'm looking at the y-axis like my mirror now. So it's going to be reflected, which means it's going to go and be over here. I don't care about the x-axis. Remember, same distance away from this blue line. So since this is 2 spaces this way, then we got to go 2 spaces this way. So it'll be this point right here. And this point is 2 and then -4 still. So let's go ahead and do what we did with the last example. Let's look at this coordinate and this coordinate. What stayed the same? What happened? Well, I see the -2 went from -2 to 2. So we're actually negating the x value here, so doing the opposite x value. And then what happened with the y value? Well, -4 stayed -4. So you go ahead and just keep that y value. Again, these rules here will make a little bit more sense when I show you on the next slide, but we'll do some examples so you can either use the algebraic rules or just understand this mirror example. So finding the mirror and then reflecting it across the mirror. Okay, so here is a great slide for you to stop the video after I finish explaining this real quick. Stop the video, jot down these rules of the coordinate before, and they all say x, y, because no matter where the point is, and then where it becomes when you reflect it in a different way. So over here on this left side, you see how these are the types of reflections. So if I have a coordinate right here and I'm asking you to reflect it across the x-axis like this first one is saying, the x-axis is this line right here. So if I reflect it across here, it now ends up down here. So you would keep that same x value that you had, whatever it was, but then you would negate that y value. If I were to draw a point up here, and the next time I say, hey, reflect it across the y-axis, well, where's the y-axis? The y-axis is this line going up and down. Remember, so if this is my mirror now, well, where does it go? So the blue coordinate now is on this side, the same distance away. So in this case, you actually keep the same y value that was in the point, but you switch the x value to its opposite value. And so on for the rest of these rules that I'm not going to get into, but I'll get into specific examples on the next few slides. So go ahead, pause this video, maybe rewind a little bit so all the markings aren't on here, and you're going to want to jot these rules down. You will need them for the assignment. All right, so here's our first example. Triangle ABC with these vertices. Vertices are those points or those corners, those locations on a grid where the lines meet. So we'll go ahead and first we need to plot this triangle, right? So plot A, B, and C. Here's my coordinate. Remember how to plot points. Good review. Always start at the origin in the middle and then move left or right first. So back 4. And I know you don't see any numbers here, but remember negative means you go to the left, not to the right. So back 4 spaces, 1, 2, 3, 4. And then the 2 means you go up instead of down. So back 4, up 2. So there's my A. Go ahead and put a point and plot it. Remember, pause the video if you need to go grab graph paper, because it's going to be helpful for you to do it on paper and not just watch. All right, so B is 4, 7. Go back to the origin, go over to the right 4, because that's positive, and then up 7. All right, and that's B. And then C is 5, 1. So go over 5 spaces and up 1. So that's C. And then remember, you want to make your triangle. That was pretty good with no ruler. Hopefully you're giving me snaps as you watch me draw this triangle without a ruler. Pretty straight edges. Okay, so now we have our triangle, and it's telling us we should reflect it across, and the directions are cut off here, but it's okay. the directions are saying across, reflected across the x-axis. So remember the last couple slides, you need to know which is which axis. X-axis, it helps to highlight maybe so that you can kind of see where your mirror is. And I'm using this word mirror just to kind of remind you we're reflecting, so it's going across the mirror. So this triangle now, instead of being up here, is going to be down here, and it's going to be reflected. So same distance away from this green line. So if C is here, it's one space away from the x-axis, so it's now going to be one space away in the other direction. B is up here, so let me label that C prime. B is up here, so it was 1, 2, 3, 4, 5, 6, 7 spaces away, so that means it's going to be 7 spaces in the other direction. So 1, 2, 3, 4, 5, 6, 7. And that's where B prime is. Whoa, that was not a very good line. I should not have given myself a compliment earlier. But bear with me. Okay, and then last point is A. A, as you can see, is 2 squares up. So that means it's going to be 2 squares in the other direction across that x-axis. And that's A prime now. So as you can see, if your drawing is better than mine, you can see that it's like mirrored. The image is mirrored. It's reflected in the other way. And so now you just need to label the points. So A prime is -4, -2. B prime is, I think, 1, 2, 3, 4, down 7. And C prime is 5, -1. And remember the rules back on the last page. If you want to go back, that's fine. The rule is to keep the x value and negate the y value. So whatever the y value is, it's the opposite. So for A in the directions was -4, 2. And when we reflect it across the x-axis, we keep the x value. So it stayed -4, but then we negated that y value. So instead of a +2, it became -2. And you could do that with each point. So it's up to your preference whether you want to use the rules or whether you want to graph it and move the figure in the way it's asking you to be reflected. All right, we're going to get into a couple more examples and then time for some practice. All right, here we go. Another example, rectangle. Okay, well, that's helpful. I know that I'm drawing a rectangle. So let's make sure when we plot these points, one, that you just make sure it's a rectangle. And if not, just double check your points. So go ahead and plot these. P is over 1 up 2. So that's P. It's always helpful to label your points as well. Q is 2, 5. So over 2 up 5. R is 8, 3, so over 8, and up 3. And then lastly, S is 7, 0, so over 7, up 0. And as you can see, I wonder if I can draw straight lines on here. That might be a good thing to figure out, huh? I'll do some research. Let's just keep going. All right, so then connect the dots, connect your points. Your figure should look way better than mine, but there's our rectangle. Wow, really, I gotta work on this. I hope you all are not laughing at my drawing, and I hope this is making sense. Let me erase it. Be patient. Patience is a thing I've been working on very much so during quarantine. All right, so there's my rectangle. The directions asking us to reflect it over the y-axis. So again, I just like to highlight to recognize where the y-axis is. There's my mirror. So you can kind of ask yourself, okay, if that's where it's being reflected, where do we think the figure is going to go? Down here? Well, if the green line's my mirror, then no, it's not going to go down there. It's going to be reflected across the mirror. So I know it's going to go over here somewhere. So let me get that out of the way. Okay, so it's going to be reflected on this side. So let's go ahead and plot the points. You can go ahead and pause the video, maybe try the rules, see if you can come up with the coordinates without the graph and test it both ways. So Q, instead of being, well, let's do P. Instead of P being right here, I'll use a different color. Instead of P being right here, it's going to be one direction across the y-axis. So P prime will now be there. Q, instead of being 2 spaces this way, it's going to be 2 spaces that way to the left. Same y value though, right? Didn't go up or down at all. So that's Q prime. R, so I see R's over here. I'm just going to go straight across back to that Y, and now I'm going to go that many spaces to the left. So how many was that? 8. So I got to go 8 spaces this way. And you don't have to draw all these lines, and if it's confusing you, I apologize. But so now, what is that? R prime is over here. And then the last one is S. S looks like it's right on the x-axis, so it's going to be on the x-axis, but at -7. So you can count back 1, 2, 3, 4, 5, 6, 7. How did I know that? Because I remember S being 7, 0, so it's going to be back 7 to -7. So that's S prime. Connect them, make sure you actually drew a rectangle or whatever the shape is, and then make sure you just give it a good visual and look at it and say, okay, that does look like it's reflected. So now label the points. P prime is -1, 2. R prime is -8, 0. Oh, I apologize. Hopefully you were like, wait a minute, that's not right. -8, where's R prime? Right here. So it's -8 up 3. Q is -2 up 1, 2, 3, 4, 5. So -2, 5. And then S prime is -7 and up 0. And if you need a refresher on how to label coordinates, please just go to YouTube. You know, don't be ashamed of it. Get the practice now. Email me. Like, I will go over it with you until you understand it and you remember it. Okay, what's the rule? Like the algebraic rule. If you want to pause it, go back to the last slide. If you're reflecting across the y-axis, what's the rule? The rule is to keep the y value. But what do you do with the x value? You negate it. You change you have the opposite x value. So for P, what was P in the directions? P is 1, 2. That's the coordinate set in the directions. And now P prime became -1, 2. So remember, keep the y and then negate the x. And that'll work for the rest of the coordinates as well. So 2 different strategies. Both of them work just the same. Okay, I think I have a couple more examples. It's a good thing Artemis is not snoring in this video. Hopefully you're not either. Let's see here, triangle. JKL, let's plot J first. So 1, -1. Plot and label with the letter. 2, 3, so over 2, up 3. That would be K. I don't need a parenthesis. I'm not going to say I'm a little rusty, but I'm just saying we're having some issues. Okay, and L is 3, -2. So over 3, down -2. So that's L. So connect them. Hopefully this one looks better. Ooh, it's pretty good. Of course, though, the J's in the way. So move the J over here and then connect them. All right, there's my triangle, y'all. Whew. Now it says, okay, so now we got a different direction. It actually says to reflect it across x equals 4. Well, what does that even mean? Well, you know that this is the x-axis. Let me go ahead and highlight the x-axis in blue. You know that this is the x-axis. So where is x equal to 4? Well, this is 1, 2, 3. This is when x equals 4, right? So now this is your new mirror. It's not the x-axis, is when x equals 4. So this is when x equals 4. So now this whole vertical line or this space right here, this asymptote, is your mirror now. So we're reflecting this triangle across x equals 4. So if K was right here, well, now where is it? Well, it's across the mirror. So it's 2 spaces away. So now it's going to be 2 spaces to the right. So K prime. L is now over here on the right side of that mirror, so L prime, and then J going directly across. Remember, same amount of spaces, so I think that was 3 spaces away is now going to be 3 spaces this way. And remember, you don't have to draw all these squiggly lines like I have, but I want to make sure that you're understanding where the mirror is and how many spaces. So go ahead and connect your points. I don't know why I'm switching up colors. But there you go. So there's a triangle. They should look similar. They should not change in size or shape. So I'm going to make sure this is a little bit better. And now I have triangles that are reflected when x is 4. So that's my new mirror. So what are the points? And you could pause the video, see if you can label the points, or if you had the points before I did. Oh, I don't think I labeled J prime. There's J prime. So that would be, now it's kind of tricky. Don't think that this is over 3 down 1. Where's the origin? Way over here, right? So let's see here. I need a new color, but we're having some technical, oh, there we go, red. Okay, so here's the origin. So where is J prime? Well, let's go back. So 1, 2, 3, 4, 5, 6, 7, and down 1. So J prime is 7, down 1. L prime is right here. So where's that? 1, 2, 3, 4, 5, and down 2. And then K is over 1, 2, 3, 4, 5, 6, and up 1, 2, 3. So 6, 3. There's also rules for these, so you can go ahead and, why don't you just take a guess? So look at J. So let me just write down J. So you can, it's good to just problem solve too. If you don't want to memorize the rules, just think about what they mean. So J was 1, negative 1, right? So what does that mean? So it was the mirror was at x equals 4, and 1 is 3 spaces away from 4. So that means you need to go 3 spaces and then 3 more spaces, which is adding 6. So now you get to 7. If I just confused you, just take a minute, think about what I said. Go ahead and graph it if it works to graph. If not, though, and you want to look at that rule, you can memorize it or just look at where the mirror is and go from there. All right, I think this is the last example. If you are watching this example, snaps to you for hanging in there with me and for listening, hopefully it's helpful. If not, you need to give me feedback because I really want to make sure it's helpful. So let's go ahead. Last example, triangle MNP. Let's go back to black. Okay, so when I plot this first one, this pre-image, I like to have it in black. And then change the color for the image. Okay, M is -6, -8. So back -6. Again, if there's no numbers, you can make numbers. Remember, on a number line, it goes -1, -2, 3, 4, 5, 6, and then down -8. And it's this last spot right here. That's M. And then N is -1, -6. So back to -1 and then down 6. Put a point, label it N, and then -2, -8. So over -2, down 8, and I believe it's this last one again. So that will be P. So go ahead, connect them. Oh my God, connect them. There's my triangle. And it's saying to reflect it across y equals 5. Okay, so what axis do you think we're going to highlight here? Y. So here's my y-axis. And I want to know where y equals 5. I probably shouldn't highlight. Let's just look at the y-axis. Where does y equal 5? Well, on the y-axis, -5. On the y-axis, -5 would be, here's -5. So this line all the way across is now our new quote-unquote mirror where we're reflecting. And if highlighting and writing mirror helps you, do whatever works for you. So again, N is 1 space away from this mirror, so going the other direction, it now is here. And P was here, and that's 3 spaces away, so now it's going to be 3 spaces in the other direction. So that's P prime, this one was N prime, and lastly M was 3 spaces away over here, so it's going to be 3 spaces going up. So that's M prime. Connecting them, they should say the same size and shape, just only reflected. So let's label these last coordinates. So M prime is now 1, 2, 3, 4, 5, -6, and down 2. P prime is -2, -2, and then N prime is -1, -4. All right, now if I went through that quick, pause the video, go back and watch it again. This video is already kind of long. I'd love to keep talking to you and doing more examples, and I would be more than happy to do that on my office hours. So please come join me Monday, today probably, if you're listening to it on Monday, at noon, 12 o'clock. The link is on the office hours sheet, on your assignment sheet, or email me if you don't have the link. All right. Take notes, watch this video again. Let's get more than 10 views this week, all right? Let's really dig into learning, and let's just continue to kick butt with these assignments. Y'all are doing a great job. Let me know if you have any questions.